Okay, let's do another review video. This is for IM3 second semester. And what we want to do, guys, is jump right to this. There is something called change of base. Basically, you ought to understand it. It works like magic. So, if you look at my expression right there, I have the log of 8, base 3. That 3 right there is the base of the log power. Now, let's say you don't even know what logarithm powers mean. The important thing to know is they're the inverse of a power function. Okay? And know that I can't type this over here into my calculator. Okay? So the only way to do that is I have to use change of base. And hopefully you can see right here, all I do is take the log of 8, divide by the log of 3. Hopefully you can see the link right there. And likewise, what about if you had to do the log of 157 base 2? Well, you just simply do the log of 157, divide by the log of whatever the base is, which in this case is 2 again. So hopefully this makes sense as we go through the problems. So pause the video if you want to take notes on that. So, starting with 31. Now this one works out kind of silly. Just want to give you a little warning here. But basically what I'm going to do is, let me first start by rewriting the equation with some more space here. But there are several ways we can solve this, but I'm just going to do one direct way. I see a 3 power base right here. Both of them are actually 3 power bases. So how do I get rid of a 3 power? You see, is I do its inverse. The inverse of any power, again, as we just talked about, is a log function. So I'm going to do the log base 3 on a 3 power. And what that does is it kills off the 3 base power there. Same thing over here. I'm doing the same thing to both sides of the equation. The log base 3 right here kills off the base of the 3 power there. Notice the only thing left is 2n equal to negative 2n. And no matter how you try to solve this, n is going to end up being 0, right? There's no other answer but n equals 0. Some of you may have gone ahead and added 2n to both sides. So we would have ended up with 4n equal to 0. Again, what's n going to be? N's going to be 0. Pause the video if you need to. So this one here, we're actually going to use our calculator to help us, as you'll find out. So let me go ahead and rewrite it, leaving some space in there to work with. So again, notice this one has a base on the powers 216, right? So how do I get rid of a 216 power, you see, is I'm going to do a log base 216 on it. And of course I have to do the same thing to both sides. And the idea is the log of 216 cancels out the 216 base, and I'm just left with 2x equal to this over here, the log of 36 base 216. But now, as you'll see, I'm going to use my calculator. And hopefully this is large enough for you to see. I went ahead and I did the log of 36, 1.55 and some change. I divided by the log of 216, right there. And because 2x equals it, I went ahead and divided by 2, and here's my answer. Okay, so let me go ahead and show my work here. As a matter of fact, let me just shift this over here a little bit. So when the log of 216 cancels out the 216 base, I'm left with 2x equal to basically the log of 36 divided by the log of 216. See, what I did was use right here the change of base rule. And that's what I did on my calculator over here to the bottom right. And I end up getting 2x equal to 0.66666. And once I divided both sides by 2, which I did on my calculator right there, I know x is simply 0.3333. also known as 1/3. So pause the video if you need to. Okay, let's speed things up a little bit. I'm giving myself some more room to work with here. So what am I going to do this time? Well, since it's a 3 power, let's do a log base 3 on that 3 power. So we're doing a log base 3 on both sides. What does that do again? The 3 base goes away. I'm left with this right here. 2a minus 3 equal to this right here is really the log of 81 divided by the log of 3 using change of base. Once I figure out this answer, I'm going to add 3 to both sides. Once I get that answer, I'm going to divide by 2. And that's what I did on my calculator over here. Let's make sure we did it correctly here. I went ahead and did the log of 81, 1.9 and some change. I went ahead and divided by the log of 3. I got 4. We then took that answer and added 3, as you can see right there. We got 7. We then divided by 2, 3.5. I now know A, therefore, is simply 3.5 or 3 1/2. Pause the video if you need to. Okay, so what are we going to do here? Notice the 216 power. So I'm going to do a log base 216 on both sides. Hopefully you allow me to squeeze it in there. So with the 216 base gone, negative 2n equals this, which is really the log of 36 divided by the log of 216. This is the change of base formula again. What's the only thing left to do is once I find this answer, as you can see over here, I just need to divide both sides by negative 2. So let's see what happened. I went ahead and did the log of 36, 1.556 and some change. I went ahead and divided by the log of 216, 0.66666. I divided by negative 2. I got negative 0.3333, so I know n is negative 0.3333, which is also known as negative 1/3. Pause the video one more time. Okay, one more problem. No, actually, that's it. So, guys, that introduces you to two main things. The change of base formula, which is something you must know because, again, you can't do these calculations with a calculator without it. And the idea that to get rid of any power, you basically do a log on it because a log function is the inverse of a power function. See you in class.